x. Which means we differentiate this once. And when you differentiate a cosine expression, the first thing is you get a minus. Right? And then the omega comes there, x, then cosine becomes sine omega t. I'm checking that we understand these things from maths already.
That's correct.
Then further on we go on to find then the acceleration. What is acceleration? dv by dt, which is the second derivative of x. And we can write that. Again, we differentiate. So for sine, the sign doesn't change. So the minus remains minus. Omega comes there, it becomes omega squared. X, sine becomes cos omega t. We are not going into the analysis of these things now. We did that for the younger generation. So today we are not going to find the other expressions, how we use this. No. We are not worried about all those things. Now let's look at this expression here. Let's write it on its own. X is equal to minus omega squared x cos omega t. Let's look at this x cos omega t. What is that? Is this, ne? So in place of all that thing, we can simply write x, which means our expression becomes, if we now take it to this side, plus omega squared x is equal to 0. Are we all on the same page now? We are now all on the same page. This is what I thought we would just remember. Right. Now that we have two expressions for a vibrating system, which is the same system. So we can express the system this way. We can express it that way. Now we want to make sense out of it. The good thing is we understand what omega is. What is it? It's a speed, ne? In rad per second. Now when we come to, okay, that was for what? For circular motion. For vibration, we call this the natural frequency. And comparing these two expressions, you see that they have exactly the same variables, x dot dot and x dot dot and x. So if we express them in exactly the same way, we are going to write x plus k over m x is equal to 0. And now they look exactly the same. And if they represent the same system, then the coefficients for any variable must be the same. Which means we can then say this is 1, 1. That's fine. This is k over m omega squared. What does that mean? Omega squared must be equal to k over m. Because it's the same system expressed in two different ways. But using exactly the same variables. Are we together? And in our case, because now we are grown up, we are always going to put an n there. This is the undamped natural frequency, because we are going to meet a whole lot of frequencies. This is the first one, the undamped natural frequency. What does that mean? That's the frequency, natural frequency of the system when there is no damping. As you can see, what we have done at the moment is to analyze something where there is no damping. And this is the result. And what it means is we can go on to then find the